Hi, geometry students. Mrs. Fallon here. I am going to go over kind of the rules for factoring. So hopefully this makes a lot of sense, and then we'll kind of do some practice and I'll show you kind of different methods. So first of all, when we factor something, that is different than solving, right? So factoring is just kind of like reducing a fraction, like writing 1/2 the same as writing 2/4, the same as writing 100 over 200. It's just rewriting it in a different equivalent form. That's what factoring is. So there's a few different rules when it comes to factoring. So when we have factoring, okay, what I like to look at first is we have something called a trinomial. Do you know what a trinomial is? So for those of you who are unfamiliar with that term, a trinomial means 3 terms, okay? So that means like there's an x squared, an x, and then like a constant term, or any other letter, it doesn't really matter. We have a plan of attack when it comes to a trinomial. So when you have a trinomial, your options are generally to always start with the GCF. See if you can factor out something they have in common. To be honest with you, this is the step that a lot of people miss, and it's actually pretty crucial. Number one, it makes the rest of your factoring, if there is any, a lot simpler. And number two, your problem wouldn't be considered completely factored unless you factor out a GCF. All right, so after you've done the GCF, the method I'm going to kind of highlight is called the AC method, and I'll go over that here in a bit. But that's generally what I use when I'm talking about factoring trinomials, is the AC method. I also use guess and check a lot, but if you're just starting out with factoring, it's nice to have kind of a plan, and that's what this AC method will do, is kind of give you a plan. All right, some other options. At this stage of the game, you probably will encounter binomials. So binomial, just like this were 3 terms, well, guess what? A binomial means 2 terms. So in binomials, there's really 2 different factoring patterns that we could use. First and foremost, GCF. Always use that GCF, and that's going to be extremely crucial when it comes to a binomial, because in a lot of cases, factoring out a GCF, whether it's a number, a letter, or both, may be your only option. It might be your only factoring thing that you can do. The other one is called difference of squares. And I'm not sure if you learned this last year or not, but if you didn't, let me show you what difference of squares means. So in a simplistic form, it would be something like this: x squared minus 16. We call this difference of 2 perfect squares. X squared is a perfect square, 16 is a perfect square. The word difference means subtraction. So this is a factoring pattern that only works when you are subtracting 2 perfect squares. It happens a lot more frequently than you might think, but so that's why we kind of talk about this method. So what I want to make sure you understand is that if I had the sum of 2 perfect squares, this is not factorable. Only the difference of 2 perfect squares. All right, so anyways, you might notice here this is a binomial, right? 2 terms. There's no middle term, all right? So that's what makes this different than the trinomial. How this factors is we set up our 2 sets of parentheses, and then you take the square root of the first term, and then you take the square root of the last term, and you make one parenthesis positive and one parenthesis negative. And so if you were to FOIL this out, that's the nice thing about factoring. You can always check your answers by FOILing this out. If I multiplied all of this out, what would happen is I would get x squared. So I'll just show you. I would get x squared. I would get minus 4x. I would get plus 4x. And I would get negative 16. Do you see how these middle terms cancel out? So this pattern of having the same terms, so like x and 4 and x and 4, but one parenthesis positive, one parenthesis negative, causes my middle term to cancel out. It does not have to be in that same order. Like it could be x minus 4 and then x plus 4 in this parenthesis. It really doesn't matter. So again, something like x squared minus 49 would factor into x minus 7, x plus 7. Be careful though, because you could have had something like 50a squared minus, we'll say, 16. So we're just going to go with that. This doesn't look like a difference of 2 squares, right? Because 50 is not a perfect square. However, remember our first rule of factoring. factor out a GCF. So 16 and 50, I think, only have a 2 in common. And I did that wrong. So let's change this 16 to an 8, because otherwise it won't make sense. All right, so I'm going to do 50a squared minus 8. I apologize. But to factor out a 2, same kind of deal. I'm left with 25a squared minus 4. It's important that you're not dividing by 2, okay? We're not just randomly dividing. You do that and you change the value of your problem. It's no longer equivalent. You always want to think of factoring it out, never like dividing both sides, or there is really no both sides because this is not an equal sign. There's no equation here. So now you see how I brought the 2 down. 25a squared minus 4, those are both perfect squares. I would get 25, the square root of 25 is 5, so I get 5a and 5a, and then the square root of 4 is 2. So I would get 5a minus 2 and 5a plus 2, and then with the 2 out in front. Again, your goal is if I FOILed all of this out, distribute all of that out, it should give me where I started. In this case, 50a squared minus 8. Let's go through another thing. So that's what we did with difference of two squares. Let me show you the AC method for those who are interested. You may have learned a different method for factoring, and that's fine. As long as it works for you, that's all I really care about. But in case you want another method, or if you just want to see something different, or maybe you don't even have a method for how to factor, let's start with this. The nice thing about the AC method is when you get into Honors Algebra 2 and you're factoring polynomials, which is something generally higher than quadratics, right? So something to the 3rd power, something to the 4th power, 5th power, and beyond. We use this same technique to factor like a 4-term polynomial. So that's what's nice about it, is you're gonna have to know this eventually, so we might as well learn it now, right? All right, let me give you a problem. So 3x squared plus 11x minus 4. Again, this is not solving. There's no equal sign. We're not solving for x. We're just rewriting this in an equivalent way. All right, AC method. We call it AC method if you might be familiar with like the general form of a quadratic. It looks like that, ax squared plus bx plus c. So a is the number in front of x squared, c is the number by itself, right? So when we call this the AC method, I'm asking you to multiply together the a and the c value. So 3 times negative 4 is negative 12. So a lot of times I just write it on the side. And the more comfortable I get with this, the less I have to actually write things down. I'm going to then look at factors of 12. Okay, 1 and 12, 2 and 6, 3 and 4. I think that's it, right? You are looking for factors of 12, okay? These numbers have to multiply to this. So I need to find a pair of numbers that multiply to negative 12, but add to this middle term. So which set of numbers I can get to multiply to negative 12, but add to 11. So generally what I do is I look at my numbers and I say, okay, 1 and 12, 2 and 6, and I look at 3 and 4. The only way they're going to add to 11 is if I can add or subtract these two numbers together to equal 11. There's no way to add or subtract 3 and 4 to give me 11. There's no way to add or subtract 2 and 6 to give me 11. 1 and 12 is my only choice. So let's play around with the signs. In order to get positive 11, I need to have a positive 12 and a negative 1. So if I added these together, they give me positive 11. If I multiplied these together, they give me negative 12. So once you've done this part, you've done the hard part. So you've figured out your factors. So now you change this into a 4-term polynomial. We keep the first term. We're now going to substitute in negative 1x and 12x in for 11x. So it would look like this. And keep the last term. So it is, all we really did here was substitute in, I mean, again, see how these are equivalent? This is 11x, this is still 11x if I added those together. You can put these in the other order, it really won't matter. You might have a little different looking work, but we'll still end in the same place. Okay, so we went from a 3-term polynomial to a 4-term polynomial. Cut it in half. Here comes GCF. So look at the first 2 terms. What do they have in common? You might notice they have an x, so we factor out the x. Carry down this sign. So I'm going to put down the plus sign because that's what that is. What does 12x and negative 4? Find the GCF for that. So in this case, it would be 4. And then what I'm left over with is 3x minus 1. Notice that these two parentheses are the same. That is intentional. If it's not the same, then you did not factor correctly. So we have to get these to be the same. So either A, you made a mistake, or there's possible that this problem is not factorable. But obviously the ones I'm giving you today are going to be all factorable. Okay, if you look at this term and this term, they both have a 3x minus 1 in common, so we're going to take that out. And then what's left over is x plus 4. This method may seem like it's a process, but trust me, the more you do it, the easier it becomes. Let's do another one. Let's go with 10x squared minus 27x plus 5. So something a little bit larger. So same process, multiply A and C together. So I get positive 50. You can sit here and start listing the factors of 50, or you can just start thinking of the ones that would add or subtract to give me 27. So it's really up to you. Rarely is it going to be 1 in 50 or 1 in whatever, but you never know. 2 in 25, 3 doesn't work, 4 doesn't work, 5 and 10 works, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10. Okay, so those are the factors of 50. Which ones would add or subtract to give me 27? Well, it's pretty obvious, right? Those two. So in order to get negative 27, I would need this to be negative and this to be negative, because they would add to negative 27 and multiply to 50. All right, rewrite your problem. So 10x squared, I'm going to write as negative 2x and negative 25x. Keep the first and last terms. Cut it in half. Factor out a GCF. So I'm going to factor out a 2x. I'm left with 5x minus 1. Carry down the negative. Factor out a GCF. Looks like it's a 5. Should be x minus 1. Should be what I have left over. You can double check by dissing it out, but it does work. Again, these two parentheses have to be the same. So my final answer is they both have 5x minus 1, and then 2x minus 5 is my final solution. Okay, so what I would strongly suggest, and there are some problems I think I gave you on on Canvas that had you practice, and so there are a bunch of different kinds of problems here. So your first rule would be to factor out a GCF. Okay, so that's what I want you to look for. And then if it's a binomial, okay, I want you to look for difference of two squares. If it's a trinomial, you can either try guess and check on your own. If you feel like you're pretty confident in that, you can kind of figure it out, or I would like you to do the AC method. So I'm just going to do a couple of these problems on this page. I'm not going to go through all of them, but I'm going to look at, I'm going to go with number 6, for example. So notice, binomial, 16a squared, 36b squared. I would start by factoring out a GCF. And the reason why is because you want to factor completely. So look at the directions. Factor each problem completely. That includes factoring out any GCF. All right, so what can we factor out of here? I know I can factor out a 2. Could I factor out anything else? I could factor out a 4, right? So I'm going to factor out a 4. Doesn't look like I can factor out any letters. So I'm going to be left with 4a squared minus, what is that, 9b squared. Okay, so I looked at my GCF, step 1. Step 2, now look to see if you have a difference of two squares. I do. 4 is a perfect square, a squared is a perfect square. 9 is a perfect square, b squared is a perfect square. And there's a subtraction sign in between. So let's set up our two parentheses. Don't forget to carry along the 4. Square root of 4a squared is 2a. The square root of 9b squared is 3b. Make one parenthesis negative, one parenthesis positive. Done. Let me show you this one. This is a special one, and this is why sometimes it's nice to have a backup plan to the AC method, because I really don't want to like 36 and 64. We call this a perfect square trinomial. And I don't know if you've learned this before, but this is a trinomial where the first term is a perfect square and the last term is a perfect square. So I just wanted to show you one like this. So what this pattern means is that when this occurs, it's kind of like difference of squares in the sense that obviously it's not a binomial, but we have the perfect square. So we take the square root of 36a squared, and I didn't take out my GCF, which I should have, but I'll show you how you can do that after as well. And then I take the square root of 64b squared. So I have 6a and 8b, because I took the square root of those two terms. In order for this to be a perfect square trinomial, I don't want my middle terms to cancel. So I don't want one positive, one negative. I want them both the same sign. So whatever this middle sign is what you put inside here. So in this case, it's 6a. It's like the same parenthesis twice. You might see it written like this, 6a plus 8b squared. It means the same thing. But remember, I didn't take out my GCF. So let's say you forgot to take out your GCF and you have this. You would then need to factor out a GCF from here and factor out a GCF from here. Otherwise, it's not factored completely. So I would get this. Oops, forgot my B. And then I would get that. And that looks a little clunky because I have a 2 here and a 2 here. So I'm just going to combine that. 2 times 2 is 4. And this is where I get this. And then again, another equivalent way of writing this would be like that. So this is a pattern that you don't see a ton of, but it is, I just wanted to show it to you just because multiplying 36 by 64 probably wouldn't have been a great choice. You could have started by factoring a GCF and then going from there, and then do an AC method, and that works as well. All right, let me do one more problem. Let's try, I don't know, let's try number 3 maybe. So 6x squared minus 17x times, or minus 28. So 6 and 28, let's do AC. It's 144, negative 144. All right, let's think of factors of 144. So obviously 1 and 144, but that's not going to add or subtract to give me 17. Neither is what? 2 and, what is that, 72? That's not going to work. 104, yeah. Does 3 go into here? Yeah, it does. So that goes into here 46 times, right? No, that's wrong. 44 times? So hang on, 3 goes in here, 24 is 8. Yeah, 48 times, sorry. So 3 and 48, that's not going to add or subtract to give me 17. 4 times, does 4 go into here? Yep. 4 goes into here, that's 2. I mean, you could use a calculator here, but I'm trying not to. So that's 26 times. Does 4 and 26 give me 17? I'm getting closer, but no. 5 doesn't go into here. Does 6 go into here? 6 goes into here. Let's see here, goes into here twice. That would be 12, 24. So that would be 24. 6 and 24. So can 6 and 24 give me 17? Does appear to be. I can get 18. 7. Nope. 8. 8 goes into here. Okay, 8 goes into here once, that'd be 8, that'd be 64, 18 times. Obviously, I know 12 and 12. Okay, so 9, that goes in there once, that's 9 and 6. I forgot 9, that's the one I want anyway. Or no, that's 9 and 6. 144 divided by 9 is 9 and 16, sorry. Okay, unless I messed up, which one gives me 17? Let me tell you this. Okay, maybe my math is wrong, which is entirely possible. So this one is kind of a more tricky one just because there's a lot of factors of 144. Let's double check. So 6 and 24, 144 divided by 8. Did I get that one right? Yeah, I got 8. And then 144 divided by 9, I got 16. So this doesn't give me 17. This doesn't give me 17. This would give me, that doesn't give me 17. That doesn't give me 17. That doesn't give me 17. Am I missing anything? So 2, 3, 4, 5 doesn't go in there. 6, 144 divided by 7. Nope, that doesn't work. 8, 9, 10 doesn't work. 11, that doesn't work. 12, so that's it. So here's why, so this is an interesting one. So in this problem, okay, I didn't get any of these factors. None of these worked. And so that's my issue. Oh, I know my mistake. I'm sorry. I know what my mistake was. It's not 144. This is 48. I multiplied wrong from the very, very beginning. All right, well, I apologize, but sometimes that kind of happens. All right, so if this were the scenario and you had no factors that worked here, then this just would not be factorable. But I made a mistake. 6 times 28 is not 144. It is 168. So let's try this again with 168. So 168 divided by, let's just kind of go with, I don't know, let's pick a number that we think is maybe a reasonable. 6 goes into here 28 times, so it's close. We can get to 22 here. 168 divided by 8, I got 8 and 21. So that one could give me 13. Let's try another one. I could do 7, so 168 divided by 7 gives me 24. Oh, that one would work. So it looks like 7 and 24 would work, because if I took 24 and I subtracted 7, I would get 17. Okay, so this one's going to have a lot of factors. So sometimes it's not beneficial to write down every single set if you know they're not going to work. So I was just trying to find ones in the middle. All right, so let's see if I can finish this one. So 6x squared, now that I have the right numbers, 7 and 24. In order for them to give me negative 17, I need this to be negative 24 and this to be positive 7. So that adds together to give me negative 17 and multiplies to negative 168. So positive 7x minus 24x minus 28. Okay, so we multiplied these two together. Now that I have the real number, I found my factors that worked. All right, let's factor out what they have in common. So my GCF here would just be x. So 6x plus 7. Looks like I'm going to bring down a minus sign. My GCF here would be 4. So I would be 6x plus 7. Notice those two parentheses are the same. So it factors into 6x plus 7 and x minus 4. All right, that's your AC method. I apologize for going down a wrong path here with the 144. I didn't realize I had that answer wrong at the beginning. Now with 168 or negative 168, we know that 7 and 24 are going to be our factors, and we can use AC method. All right, one other thing I maybe would do here is I want to show you number 7, just because this one tends to throw people off. So it's a binomial. So what you would start with is by factoring out a GCF. And it looks like 5 is my GCF. Okay, so I get, factor out of 5, I get 4k squared minus 1 is kind of what's my leftover. Here's what a lot of people forget. A lot of people forget that 1 is a perfect square. So this can be factored one more time. 4k squared, that's a perfect square, and I can do 2k and 2k. 1's a perfect square of 1 and 1. So a lot of people miss this one. So I just wanted to make sure that you guys saw something like that. So now this is 5 times 2k plus 1 and then 2k minus 1. All right, so hopefully this makes sense with the AC method. If you like this method, great. If you have a method that works for you and it's better, again, my goal is for you to be able to factor. So do with it what you can, as long as you're able to factor. That's what I care about. Remember, we're not solving any of these right now. There's no equal sign, so you're just factoring. All right, please practice that worksheet that is on Canvas and then turn it in when you're finished. All right, bye for now.